Hello students, this is Fazal Wahab. In today's class, we are continuing the relative maximum and minimum values of the function, and we will solve the last question of this exercise, which is 5.3. And the question number 11, which is given in the book, sometime it has been given in the paper like this one: f of x is equal to ln x upon x. So both method is the same for both of them. So if you are going to understand this part, so you can do this part also very easily. So now we need to differentiate this one for minimum and maximum values. So solution is f derivative differentiate with the y f of x with respect to differentiate f of x with respect to x. So f derivative of x is d over dx of x upon ln x. Okay, now we are applying here the quotient rule because two things x and ln x are dividing with each other, and we have already discussed that when two numbers or two expressions are dividing with each other, so we will apply the quotient rule. Let's say the two numbers are u and v, and these are multiplying u divided by v, and if we need to find out the derivative of this one, so how we will apply the quotient rule. Quotient rule is v denominator multiplied by derivative of the numerator minus numerator multiplied by derivative of the denominator, which is v, divided by denominator square, which is v square. That will become v square. Okay, so if I make it little bit easy for you, so we can give the low to the denominator and d to the derivative, and u high to the numerator. So low d high minus high d low over low. This is very simple. Now it will become very easy to pronounce and to speak this one. Low d high minus high d low over low. This will become easy for remembering it. Okay. So low d high minus high d low over low. Denominator derivative of the numerator minus numerator derivative of the denominator divided by denominator square. This will little bit difficult. So low d high minus high d low over low. Now which one is easy for you? You can use that one. Now here is x divided by ln x. So low means ln x, d high x minus high d low is ln x, over low means ln x square. Okay, now ln x and derivative of x is equal to 1 minus x and derivative of ln x is 1 upon x divided by ln x whole square. Now the derivative of this one, now x will be cancelled with the x, and you got ln x minus 1 divided by ln x whole square. Okay, now this is the final first derivative of this equation. Now for extreme values put F derivative of x is equal to 0. So ln x minus 1 upon ln x whole square got equal to 0. Now ln x minus 1 is equal to 0 multiplied by ln x whole square. This will become 0. Ln x minus 1 is equal to 0. Ln x is equal to 1. And okay, now we can take ln of both sides. Okay, no need for taking ln on both sides. So ln x is equal to 1 multiplied by ln e. We can write this one because don't need for 1 multiplied by ln e. I think it's enough because there will be no need for this one to multiply with the 1 because ln e is equal to 1. So we can put ln e for 1. Okay, ln e is equal to 1. So ln e for 1. Now cancel ln with the ln and you got x is equal to e. This is the value of the x. Now we will find the second derivative of the function of the first of this function for finding whether this function has a minimum or maximum value at x is equal to e. So we need to find out the second derivative of this function for checking whether x is equal to e has a minimum or maximum value. If derivative of x is equal to, okay, first derivative is the first derivative is ln x minus 1, ln x minus 1 upon ln x whole square. This is the first derivative, and we are going, okay, wait. Second derivative, find the derivative of the first derivative, which is ln x minus 1 upon ln x whole square. This one. Now again we will apply the quotient rule. So low d high, this is low, d high d over dx of ln x minus 1 minus high which is ln x minus 1 high d low is ln x square over low means ln x square whole square. Okay, so ln x whole square and d over dx of ln x minus 1 is 1 upon x, because the derivative of minus 1 will be equal to 0 and ln x, the derivative of ln x is 1 upon x only. So we will get only 1 upon x minus ln x minus 1, and the derivative of this 2 ln x whole square is 2 ln x and the derivative of ln x is 1 upon x. So we can write it upon x, because the derivative of ln x whole square is 2 ln x, and then again the derivative of ln x will become 1 upon x. So this whole will become 1 upon this one. Okay, divided by ln x square in whole square. Now put the value of x is equal to e, because the we have find the value of x is equal to e. So ln e square into 1 upon e minus ln e minus 1 multiplied by 2 ln e divided by e upon ln e raised to the power 4, 2 to the 4. Okay. Now the value of ln e is equal to 1. We know this one. So 1 square is 1. So we will get only 1 upon e. Minus ln e, 1 minus 1 is 0. This whole will become 0 because ln e is 1. 1 minus 1 is 0. And this 0 is multiplying with this one, we will get 0. Okay. So minus 0 upon ln e is 1, 1 to raised to the power 4. So you got only 1 upon e. So f second derivative of the function is only 1 upon e. Okay, 1 upon e is greater than 0. Therefore, the function has a minimum value at x is equal to e. Function has a minimum value at x is equal to e because we got by putting the value of x is equal to e in the second derivative, and we got a value greater than 0. Therefore, the function has a minimum value at x is equal to e. Now, by putting the value of x is equal to e in this function, we will get the minimum value of this function. So, we don't have the space here. I have to remove this one. For minimum value, put x is equal to e and f of x. So f of e is equal to e upon ln e. So e upon ln e is equal to 1. So f of e is equal to e. So the minimum value of f of x is equal to e. This is the final answer.